Welcome to Booleans and if statements. In this lecture, we are going to be learning, reviewing the types of variables as well as reviewing some of the terms that we've been using. There's a lot of terms when it comes to programming, so I know it's hard to keep them all in your head, so I've made a good list for you, a little glossary. And how to use Booleans and their operators. So Booleans are a new type we're going to learn about, and we're going to learn about operators and Boolean expressions, and how to do conditional execution with if statements, because the main point of this is to react to different conditions, such as a different input from the user. We want to behave, our script to behave differently. Otherwise, it's kind of useless if it's just doing static calculations. So let's dive right in. So what is the next step for our go home game? Let's have a look at our pseudocode and find out. So far we have done these first three steps, the calculation and the printing and the setting the start location. Now, next up would be to read the player's move, but there's no point reading the player's move unless we know how to update the location from home. So let's take a look at this one next, and it'll give us some helpful building blocks for reading the player's move, which we'll do in the following lecture. So let's revise the types that we have seen so far. So far we have seen the floats, integers and strings, and here are the different types that we actually use when writing it in C#. Now what we want to do is have some way of conditionally doing things. So to update the location, we want to say basically if home is ahead, we need to go back, and if home is forward, we need to go forward. So we need to be able to read in a player's move that says forward or back and update the location appropriately. So we need to do different operations depending on what the player's move is. So to do this, we need a new type, a type that's known as a Boolean. A Boolean basically allows us to have true-false questions. As you can see here, we've got the abbreviation bool, but most importantly, it's for true-false answers, and the two values it can have are only true and false. So let's have a look at this. How does this variable actually look? So I'm going to open up our Visual Studio with our console printer script. And what we want to do is create a new bool variable and print it out and just see what happens. Okay, so here we have all our variables so far, and let's create a new bool for is 2 greater than 1. Notice how I'm writing these variable names. Obviously there are no spaces allowed in variable names. You probably gathered that by now, but in order to make it more readable, I start with a lowercase letter and then I do what's called camel case, which is that every new word starts with an uppercase. So this just allows me to visually very easily see what the words are in these multi-word variable names. That's just a typical convention, and in C# that's the one we're going to be using throughout this course. Obviously there are different conventions, such as you might say is 2 greater than 1. That's also quite a common one, but we're going to stick with this, is 2 greater than 1. So let's just say, so for sake of argument, is 2 greater than 1? Yes, we know that's true, so I'm going to type in true. Remember our semicolon. And I can print this out. So print is 2, in fact I'll put numbers here, 2 greater than 1. And then we can just do a plus like we have already seen with distance. Same thing goes for bools. So let's say OK and hit play. And go into our console and see that is 2 greater than 1 is indeed true. Notice that I added a space after my semicolon, and that allowed me to have this space in the logs as well. So let's do that for distance too. Let me just make things a little bit more readable. Let's hit play, and there you go. Now we've got a space in front of distance 2. Okay, so that's fair enough, but we could actually get the computer to calculate this for us by saying, well, 2 greater than 1. So this is a Boolean expression. That is, it uses an operator and it returns a Boolean. Let's just have a quick revision of those terms that I've been using, because I know they can get slightly confusing at times. Here is our glossary so far, the terms that we have talked about. We have the value, which is things like numbers and text, and we've used a lot of values such as these string values, these floating point values, and these integer values. We also have the type, which is the shape of the value, such as the int, float, and string, or now we've even seen Boolean types. Then we have the variable, which is the box with the correct shape for the value. So we've got things like an integer, which has the shape of int, or the type of int, and a string, and so on. We've also seen statements. These are the things that end in semicolons. They are the commands to the dumb computer, the dumb actor, and they tell it what to do, basically step by step. That's a statement. And then finally, as I just said, we've got expressions, and expressions are basically any command to the computer that evaluates to a value. So for example, we have a home location minus location. We've seen that one before, and we know that this gives us a value because it's what it allows us to put it into that distance box, is returning a value. And again, this string plus the distance is obviously returning a string value because it allows us to then print that string value. So those are expressions. And as we can see here, this is a Boolean expression because it returns a Boolean. It takes in two integers, and then we use an operator, which is the greater than operator, and it returns a Boolean. So that is how we can use Booleans to calculate things for us, do some interesting maths for us. Okay, so that's all well and good, but like I said in the beginning, if we go way back to update the location from home, what we want to say is if the player says one thing, do one thing, and if the player says another thing, do a different thing. So how do we do different things based on these Booleans? Well, there is such a thing as an if statement. As the name of the lecture suggests, that's what we're going to be using these Booleans for. So what I might say is if, and then in brackets, is 2 greater than 1. And then I use these curly braces to say that within the body of these curly braces, I will only execute these commands if this Boolean is true. Otherwise, I won't execute them at all. So I can remove this print statement here and simply print 2 is greater than 1. Simple as that. And then what we can say is go ahead and check that out. So I'm going to stop playing and play again. So 2 is greater than 1. It gets printed out. But what if I set this variable to false? Let's try that too. Let's hit play. And you notice this time nothing gets printed because 2 is not greater than 1. So it's not going to tell us that 2 is greater than 1. Okay, so if statements go hand in hand with Booleans. They are why Booleans are useful, in the same way as strings go hand in hand with being printed, because that's why strings are useful. So we now know why we are going to use Booleans. We use them in something called an if statement. An if statement in here takes a Boolean expression. Here I've given it a variable, but I could have just as easily said 2 is greater than 1. And that is just as valid and will also print out because we know that 2 is greater than 1 and that is true. So you see, I've just said it and I've proved it by making the computer run and do it. So time for you to write your own Boolean expression. I'd like you to evaluate whether the location is greater than the home location, because in this case, what we need to give as a direction is that they need to go backwards, basically, in order to get home. However, if the opposite is true, then I would like you to print the correct instructions as well. So pause the video and have a go at applying your knowledge of Booleans and if statements to this problem. Okay, welcome back. Now, remember, if you ever have syntax errors that you can't quite work out, you can always go into the lecture resources and find the exact end state of this video so that you can compare your syntax to the syntax that I have written in these lectures, because sometimes it's very small things that you don't miss as a beginner programmer. You won't quite see that perhaps you have just mistaken the order of something. Obviously these squiggly lines, the red squiggly lines, the green ones are kind of okay, but the red ones will give you an indication of where to look, and do use that because those are some of the most simple and easy problems to fix. If you are new to programming, you may not have your eye quite tuned to these things just yet, but remember that the compiler is very, very finicky. So basically Unity is very finicky and will pick you up on any small error. So you need to be absolutely perfect in terms of typing these things out. But don't worry, it also helps you out by giving you those red squigglies. So here we have our if statement. I want to do, let's just check on the challenge, all that talking, and I've forgotten what the challenge is. We want location greater than location home. Well, that's fairly simple. We can actually just type that right into the if statement. No need for a variable. I'm going to remove that variable. That was just to show you that there is a type going on behind this, but often we can just do this with Boolean expressions. So we've got location greater than home location. Simple. Now, what can I say? Well, what is the instruction? If the location is greater than the home location, it's going to be go back to get home. Now, let's test that out. Yes, go back to get home. That's because the location is greater. But what if my location was less? Then nothing is printed. I have no instruction. That's a bit useless. So what should I do? Well, I'm going to say if location less than home location. See, this is a different operator, the less than operator. Well, then we print go forward to get home. Remembering my semicolon because Visual Studio was reminding me with that helpful little squiggle. So let's try that out. Let's print. Play, and then we get go forward to get home. So no matter what our location is, we are now getting the correct instruction. Well, is that quite true? Let's just try that out. If we got 2.1, oops. So we are at home. What's going to happen then? Let's play. No instruction, because neither of these two statements is true, because it's not greater than, it's not less than. The only thing that leaves is that it is equal. Now, how do we do equality? You could try location equals home location. But what you'll find is a big squiggly here saying that cannot implicitly convert float to bool. So what on earth is going on here? Well, basically what it's done is it's taken this equal sign to mean an assignment to the variable location. So how do we make it a Boolean equality? Well, let's have a look at the Boolean operators we've seen so far. We've got the greater than, we've got the less than, and this is the operator we need for equals, two equal signs. A bit weird, I know, but the important thing is it distinguishes it from the assignment operator we've been using before. So this is the assignment operator, equality, equals, like that. Whereas the equality operator, the one for Booleans, is a double equal sign, like so. And so here we can say print, I am at home. Let's go back in. And there we go. We have sussed out the equality sign. And just one more Boolean operator, there is also a not equal sign where you put this little exclamation mark. Exclamation mark means not, and so we can do not equality in just this way. Okay, so now we know all about Booleans. Congratulations, that is a big step in being able to make much more complicated programs. So I will see you in the next lecture where we will be taking input and acting on those inputs instead. So let's see you there.